Good morning, everyone. I, Pratham, along with my teammate Dhruv, stand in front of you all to showcase our project that is the IntelliScout Rover version 2, and we are from team Cyber Geeks. It is basically a Spybot, and we have built this to solve some real life applications or some real life problems which humans face. Now, what are those problems? Such as it can be a threat to human life and many more things. Now, my teammate will explain you some real life applications of it.
So, as per the Pratham Aggarwal said, that what kind of the problem we are facing, the real life novelty of this IntelliScout version 2. I'm working in a technical part, and along with my teammate, he also working in the assembling or the integration part as well. So, as we face the problem that the non-human intervention area where the human possibility will not going to be occur in those area like such as kind of borewell system, pipelining monitoring system, coal mines, gold mines, where cause the human death risk. So we did not take such kind of a bigger risk, and we have to be monitor such kind of the activities by using this kind of a kind of device called IntelliScout version 2. Not only this, we also using different type of activity like space missions in order to collecting of samples and using it in different type of department like research and development department, military operations in order to gathering the real-time feedback of about without any kind of internet connectivity. Even it also work in 40 meters of range with the help of EMF signal, electromagnetic field signal, without any kind of the internet or Wi-Fi connectivity. We developed the program in the terms of C++ language and along with the integration with the Python language. Now, yes, of course, we are going to be able to integrate and we are going to be use this kind of a project over the range of out of 1 kilometer, but we need to require the Wi-Fi connectivity and we need to require some kind of a funding arrangement of about it. We can see that how it will going to be actually work in graphical user interface, that how we can going to be interpret according to the human. So let's dive deep into it. So as you can see over there, we build the two cases, the two levels of IntelliScout version 2. We implement the servo motor at the top of the view in order to gather and collect the data from surrounding of our environment. We use ultrasonic sensor interconnected with it. It acts like a radar system we use such that if any of the other kind of obstacle which occurrence and which makes some kind of interruption problem during traveling or during at the time of monitoring, so it sends the ultrasonic signal to the object. If any of the object will going to be interrupted, it will going to be reflect back and gives the output data here, and that particular kind of a data will going to be passes at the nano part, and then it will show the light of the in terms of green parameters to red parameters. What actually the green or the red parameters, like let us suppose this my hand is an object. If it is going to be interrupted in between of the cyber over IntelliScout version 2, so during at the time of monitoring, so it sends the ultrasonic signal and it sends back to the output to the ultrasonic signal sent back and give the red intensity. Now red intensity is also going to be increases whenever in terms of the meter, like whenever the obstacle is going to be nearer to the car, the red intensity will gonna increases, and when the obstacle is go farther behind, so the intensity will going to be reduces as per the meter. So angle it also going to be displayed on a real time basis. Now how it will going to be implement, we let's dive into it. So now we connected the connector with the nano part, because all the data will going to be gathered from surrounding of environment. It will be going to be directly connected over it. As you can see over there, the servo motor takes 180 degree of angle because it takes data and gather the data from it. We developed the program in C++ language along with the integration of HTML code to see the GUI interface. Now it is clearly visible that how it will gonna work. If any of the obstacle, let's suppose this obstacle is going to be interrupt in between of it while during at the time of monitoring. Let's suppose take an example. We monitor the system in coal mines, bore well, where internet connectivity is not gonna possible. So if any of the obstacle like rock or any other kind of sand, so we can take and monitor in terms of angle that how far it from the car IntelliScout version 2. So we can take the action according to it. So as you can see over there, whenever the obstacle comes nearer to it, the red intensity will gonna increases, and it also give the distance and angle on a real-time basis at on same interval period of time. Now whenever the obstacle go farther behind, so the angle and the distance will going to be changed and the green parameters will show. So this is all of about cyber radar, that how it will going to be work, which helps us to monitor different type of scenario as you can see over there.
Okay, so as you can see, here is our camera. The technical name for this camera is the ESP32 cam, and we have integrated it with our private IP. It is static in nature, and we have done this thing to ensure that our camera and our rover can work in low light conditions or in areas where there is no internet connectivity. It can work up to 40 meters of range solely through electromagnetic fields without the need of Wi-Fi, Bluetooth, or internet. Now it has also a headlight integrated with it, which we can control remotely through our tablet interfaces, through our laptops or our phones easily. And we are also planning to integrate a remote control for it in the future, and we will also be implementing some infrared sensors, water sensors, and other things. Now here is our lithium ion batteries. We have used three lithium ion batteries of 2000 mAh each, which totals up to 6000 mAh. Now these lithium ion batteries are totally rechargeable. Right now we are using our camera with the help of a power bank. We have integrated power bank to make it more like remotely operatable, but we can also implement a battery system with it. Now integrating power bank allowed the camera to work seamlessly, and there was no lag in it. Now let's explain you that how it works, and show you our interface.
So data will going to be gives in terms of frequency 00, 11, 22, 33, 44, and 55. As the light will going to be increases, the data signal will going to be passes with the nano part, and then it will going to be send reflect that how it will going to be connected with the private IP. And you can see whether light will gonna increase and decrease with the 55 value frequency, with the 44, 33, 22, 11, and then 0. As same as we use the concept in terms of speed as well. Okay, now how it will going to be used in terms of left and the right moment part. We use to balance the momentum of this IntelliScout version 2, because different type of scenario we did not able to rotate this kind of upper lower wheels. So we use the programming code that if the one once this two particular kind of wave nature of the tires, which if they are moving in a forward direction, then the other two motor drivers will act oppositive, like in a terms of opposite manner they will move in a terms of backward direction. How it will going to be used that, let's suppose whether we used to take the right turn, so they will move in the terms of forward direction, but they will move in the terms of forward direction, but it will going to be move in backward direction, so it will going to be used in terms of right. And just the same in terms of scenario in terms of left hand direction as well, as you can see over there, left and then the right. So the two motor levers are interconnected with the one-sided part, and other two they are connected with the one-sided part, and we combine them in a hybrid mode and with the alternatively motor driver. They in the terms of left-right motion they move in opposite direction, so that they can take moment accordingly and safely. Now how it will going to be used in different type of applications, and we can take some kind of shots that how it will going to be used. So as you can see, different type of scenario what we can use in the terms of future scope. I wanted to say humidity sensor, just like a radar system. We've also gathered the data of about our environment. We also use to gather the data of about like pressure, humidity, what kind of scenario of that particular kind of situation or the environment, such that we also use in an advanced level in a category. We also implement like already explained robotic arm in terms of space missions in order to gather and collect samples, and we also research in terms of Department of Research and Development by ISRO, DRDO, Defense Research and Development Organization, and by ISRO and many other kind of space agencies as well. We also use IntelliScout. With the name IntelliScout version 2, we also define that the spying bot. The spying bot we basically develop for the military purpose as well, in order to spying, in order to gather the monitor the data about enemies. So that's what I mean. So we also implemented and we also move into the advanced integration as well. So that's all of about it. Thank you.
Thank you.
Thank you.